we are just going to draw a Bohr model for sulfur to see if we remember how to do Bohr models, because it's been a while. Yeah, you should have. Yeah, absolutely. The first step in drawing your Bohr models, you need to know how many electrons. Yes. We know that there are 16 electrons because that number at the top, tell your partner what that number is called. That is the atomic number. And the atomic number is equal to what? It is equal to the number of, technically what it is the number of protons. So we have 16 protons. So we have 16 positive charges. Yes? We know that an atom is neutral, which means that overall we want to have a zero charge. So how many negative things do I need to add? 16. Okay, so 16 negative and 16 positive gives us 0. So we know we have 16 electrons. Okay, yes, Aaron? If I request the number of protons and neutrons, then yes. For this, you don't have to. Yeah, it's going to depend on it. You would need the isotope number. You would need the mass number. Shh. This is not the mass number. Okay, and we're going to learn about that today. Why is atomic mass not the same as mass number? Because it can be really confusing. Okay, so we'll talk about that later today. Alrighty, so you have 16 electrons. And if you haven't had a chance to put those electrons on your model yet, try it out. Okay, see how that goes, and we'll check back again in a minute. Okay, most of you have remembered in our center we have the nucleus. I'm just going to call it positive for now. You can just put a dot there if you want to. We have 1, 2 on the first shell, and they have to go together on the first shell. That's 1, 2. Then we have 3, 4, 5. Remember, go around the circle. You don't pair them up until they have to. 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16. Okay, and if that's seeming unfamiliar to you, drop by maybe after school today or Monday Flex, and I can go over it with you if you found that complicated, okay, or troublesome. All right, excellent. We are going to now go back to isotopes on page 85. Page 85.
What are isotopes? Isotope is a word that gets thrown around in chemistry a lot. So, like, what are they? Really isotopes are different versions of an element, or different versions of a certain kind of matter.
Don't worry, we're
It's
going
a
to
tricky concept, though, and a lot of people get
zoom ahead to where we were.
isotopes. So I want to describe them by starting out with an analogy. So that's how we distinguish between these different isotopes, different types of carbon. There's another way that we sometimes indicate these different isotopes and atoms instead of doing 12, 13, or 14.
Do you remember what the other way was? We can write the word carbon, we can write a dash, and then we can write the number. Tell your partner what that number, say 14 carbon, 14, what does that number represent? Tell your partner. Okay, let's start with, what is the name of this number? Yes, it is actually not the atomic mass. That's the thing it is most often confused with. The 14, what is that number called? Yes, it is the mass number, okay? Mass number, and it is different from atomic mass, and today, after this, we're gonna learn why, okay? So don't worry, we'll get there. Now, that's what we call it, but what does it actually stand for? What information do we get from that number? Tell your partner, what information do we get from the mass number? Aaron. The number of what? Total particles. What type of particles? In the nucleus. So it's the total number of particles in the nucleus. What are the two types of particles in the nucleus? Protons and neutrons. So this is the total number. So you know the number of protons and neutrons together is 14. Now, we're going to write a capital C here. Which number do we put on the top? Do we put the 14, the 6, or the 8 on the top? 14 goes on the top, and then 6 goes on the bottom. The 8 doesn't go anywhere, but you can find it by taking the 14 minus the 6.
And that's by using something called isotope notation. Let me show you how we do that.
Okay, we're going to just skip ahead here because we've done this already. La 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 la. There we go.
Then the number. So carbon isn't the only type of element that has multiple isotopes. In fact, just like cars, almost every form of element comes in multiple isotopes. Here are the calcium isotopes, for example. If you look up on the periodic table, you'll see that calcium has an atomic number of 20.
Okay, so now actually, I'm going to zip back here. Am I? No, it's okay. So if you were to look at this, that video's not in the right place. I need it to be somewhere else.
It has an atomic number of 20, which means that any atom that has 20 protons in its nucleus is calcium. But just
so, what is the mass number for calcium here, where it has 20 protons and 24 neutrons? 44. How do you get that? You add protons plus neutrons. So one of the things I can do is, if I give you the number of protons and I give you the number of neutrons, I can say, what is the mass number? Yeah? So I give you protons, I give you neutrons, you add them together, you can find the mass number. The other thing I can do is I can give you the mass number, 48. I can give you the number of protons, 20, and you can calculate 48 minus 20 is 28 neutrons. But I always have to give you either the mass number or the number of neutrons, because you can't get that information from the periodic table, okay?
Like with carbon, you can vary the number of neutrons that are in the nucleus. You get all these different isotopes, but you still have calcium. Calcium, we've got 40, 42, 43, 44, 46, 48. All of them have 20 protons in the nucleus, but they have varying numbers of neutrons.
Okay, so I'm just going to pause that for a minute if you want to fill in your blanks there. And the reason I have you fill in the blanks is so you remember to do things like draw the dash after the name. Calcium dash 44. Calcium dash 43. Yes? Yep. Yeah, you'd go 44 minus 20, so the mass number minus the atomic number gives you the number of neutrons. So if you got calcium 46, there's your mass number, minus the atomic number gives you the number of neutrons. Mass number minus protons gives you neutrons. Okay?
Just like we did with carbon, we can write all of these calcium isotopes in isotope notation, where we have the mass.
See if you can write the isotope notation for the ones that are missing it. See if you can write the isotope notation for the ones that are missing it. I think there's only 2 of them. The calcium 44 and the calcium 43. See if you can write those in isotope notation. So here is isotope notation for calcium 40. Here is isotope notation for calcium 42. Try writing isotope notation for calcium 43 and for calcium 44. Okay?
Number here up at the top, and the atomic number down at the bottom, you'll see they all have the same atomic number of 20, but different mass numbers, the sum of protons and neutrons. The same is true for iron, just to give you another example. Iron has 26 protons in its nucleus, an atomic number of 26. And there are 4 known isotopes of iron, all of which have 26 protons in the nucleus, but they all have varying numbers of neutrons. Add these together to get the mass number, and then you can write it in isotope notation with the mass number up here and the atomic number down here. So just to review what we've talked about, atoms come in different versions known as isotopes. These are like the different versions of a car or something. The number of neutrons change, but just as long as you have the same number of protons, you still have the same type of atom, same type of element. You can take an atom and write it in isotope notation, where you put the atomic number on the bottom and the mass number up here. So that's what isotopes are. What are isotopes?
No, we just did that. No, Tyler, you don't get to go again. We'll have you do a different lesson. Okay, so that's what are isotopes. Now, I've been speaking, people have been saying atomic mass, and I keep saying, no, atomic mass and mass number are different. So let's take a look at page 87. Okay, because we want to know what is the difference between mass number and atomic mass. Sadly, they sound very much the same, but they are actually different. So let's just take a quick look at this.
Let's talk about the difference between mass number and atomic mass. These things sound very similar, but they're actually very different. Just so you know, atomic mass can go by other names. Sometimes it's called average atomic mass, or relative atomic mass, or even atomic weight. Maybe your teacher calls it one of these. For our purposes, in this video, we're just going to call it atomic mass. So, we're talking about the difference between these two things. Let's start by talking about mass number.
And I know we just did this, but you're going to tell your partner what is mass number, what information does it give you. Aaron, was that a stretch or do you want to tell me? Aaron, you were stretching, okay. How about someone who hasn't talked to me yet today? Tell me, what is mass number? Yes, Joanne. The number of protons and neutrons. And it is the number of protons and neutrons in a specific isotope, okay? Now, where would I find mass number? Ooh, this is tricky. Where would I find mass number on the periodic table? Let's go look. Mass number. Oh. Uh-oh. Here I have the atomic number. Here I have the symbol, the name, and the atomic mass. Now remember, mass number is the protons plus the neutrons, and each of them weigh how much? 1 AMU. How on earth do we have this 0.1? What is going on with that? Huh? It actually has nothing to do with the number of electrons. But it's a good guess. It was a good thought. Okay? So that's what we're going to find out. So the answer, where is the mass number on the periodic table? It is not on the periodic table. I have to give it to you in the question. Or I have to give you the number of neutrons and you can calculate the mass number. But you will not find mass number on the periodic table. Okay?
So up here, I've got two atoms. They've got protons and neutrons in their nucleus, and I'm particularly concerned with the number of protons and neutrons that there are. So this atom over here has 5 protons. The protons are these red circles, we can count them up. 5 protons, and the neutrons are these blue circles, we can count them. We've got 5 of those.
What is the mass number of this atom? 10. So you could actually fill that in a little box. It says mass number equals 10. And actually, while we're here, try and figure out which element we're dealing with. Yes. This will be on, not the quiz on Monday, but it'll be on the quiz next Friday. Okay? And we'll do lots of practice between now and then. Okay?
This atom over here also has 5 protons, but it's got 6 neutrons.
What's its mass number? 11. Excellent. You can fill that in. And you can put that it weighs what? You have the one on the left weighs 10 what? AMU. And the one on the right weighs 11 AMU.
So, mass number is the number of protons plus the number of neutrons.
So you can fill
So
that
this
in.
atom here has a mass number of 10. 5 plus 5. And this atom over here has a mass number of 11, 5 plus 6. Mass number tells us how many protons and neutrons are in the nucleus of an atom. But it's also important because it gives us an idea of how much the atom weighs. You might remember we've said before that one proton or one neutron weighs about 1 AMU.
I'm going to pause there so you can fill it in. One proton or one neutron weighs 1 AMU. And once you've written that, tell your neighbor what AMU stands for. AMU stands for atomic mass unit. Good.
Atomic mass unit. So, if you have a mass number of 10, 5 protons and 5 neutrons, your atom is going to weigh about 10 AMU. If you have a mass number of 11, that tells you that the atom here weighs about 11 AMU. These atoms both have electrons, but electrons are so tiny, and they have such a small amount of mass.
Why do we ignore the electrons? They're so tiny, they don't have a lot of mass, so we just go, they don't really count.
That we don't even worry about the mass of electrons when we're weighing up stuff to determine how much the larger atom would weigh. So 10 AMU, 11 AMU. So that's mass number. Protons plus neutrons, and it gives you an idea of how much the atom weighs in AMU. Now, let's talk about atomic mass. You might notice that both of these atoms have the same number of protons in their nucleus. 5 protons here and 5 protons here. This means that they're the same element.
Which element is it? Go look, find out. Go look on your periodic table. Which element is it? Now hang on, is the atomic number 10. It's the mass number that's 10. What's the atomic number? All right, what do you have to look at to tell which element it is? You have to look at the number of protons. Protons tells you which element. So if we have 5 protons, that means what number on the periodic table is 5? Boron, because if we go to our periodic table, our atomic number tells us the number of protons. And so if we look and we say, who has 5 protons? That would be boron. Boron has 5 protons. So that's how you identify the element, is by looking at the protons. Not the mass, you look at the protons, the atomic number. Okay, cool.
Right, because the number of protons an atom has determines what kind of an element it is. So, we can look on the periodic table to find out what element these atoms are. And it turns out that they're boron, because boron up here has an atomic number of 5. 5 protons, and you're boron. So, both of these atoms are different versions of boron. They're different isotopes. An isotope is a word that just means a different version of an atom that has the same number of protons, but a different number of neutrons. We can give distinct names to these two isotopes or versions of boron. This atom over here is an example of boron 10. because it has a mass number of 10, 5 plus 5. And this atom here is an isotope of boron called boron 11. 5 plus 6 has a mass number of 11.
So you can fill that in on page 88. Okay, boron 10, boron 11.
So, there are billions and trillions and gazillions of boron atoms in the world. If we could pick one up at random, it could be either one of these two types, okay? It could be a boron 10 atom with 5 protons and 5 neutrons, or it might be a boron 11 atom with 5 protons and 6 neutrons.
So you don't know what you're going to get. Okay? I'll give you a second to fill all that in. Yes? A is just the letter that we use to refer to the mass number. So you probably won't use that a lot in grade 9, but if you take like chemistry 11, we call the mass number A. Yeah, and we call the atomic number Z. So, yes. How do they weigh them? Well, what they actually do is they actually take a whole ton of atoms, and then they find the mass of the atoms, and then they find a very pure isotope, and then they compare things with that isotope. They're not weighing individual atoms. They're weighing like a whole bunch, and they're doing some experiments to figure out how many atoms there are, so they can figure out like how much, 100 billion atoms weigh, and then they can divide by 100 billion to find the mass of one atom. Yeah? Yeah. Oh, for grade 10. Actually, that's a really good question, and I've had a couple people asking me stuff. In grade 10, you don't get much of a choice. It's just like in grade 9. There is just Science 10. If you are interested, there is a Science 10 enriched class. It doesn't matter, though, if you take that, what choices are open to you in grade 11. Whether you take the enriched 10 or the regular 10, all the grade 11 sciences are open to you. Are you interested in hearing about the Science 11 options? Yes? Okay. So we're just going to do a little public service announcement right now. There is chemistry, which is what we're doing right now. Okay? This is chemistry. It has to do with matter, atoms, compounds, molecules. And in order to do chemistry, you don't have to be awesome at math, but you should not hate math. If you hate math, you will hate chemistry, because there is math in chemistry. It's not hard math, but there is math. So if you're like, math, yucky, don't take chemistry. Same thing with physics. Physics, that's going to be things like, do you remember the waves from last year, and the lenses and all those sorts of things? This year we're going to do electricity. There's going to be forces, energy, okay? All of those things are to do with physics, motion, so like why things speed up, when they're going downhill, and why they slow down when they're going uphill, what happens if one object collides with another object. All of those things are physics. Physics also involves math. So if you're like, math, yucky, then for you, physics will be yucky. But again, it's not super difficult math. It's just, if you really hate math, don't do it. If you're okay with math, then that's fine. You don't have to be super awesome at math for either of those. You just don't want to hate it, because then you'll hate the course. Biology. Biology is the study of living things. Okay, so last year you learned about cells. This year you're going to learn about DNA and how cells make new cells and how organisms reproduce. Yes, because some of them reproduce sexually and some reproduce asexually. They'll just make a little clone of themselves. In fact, there's one organism that's got like little tentacles on its head. It's called a hydra. And it actually grows like a little clone that comes out of the side of its body, and then the little clone just falls off, and you have a brand new little hydra. So that's biology. In grade 11, you study all sorts of different kinds of animals and plants. And then in grade 12, you would study anatomy and physiology, which is like the human body. So you would do like all the body systems, how they interact, all that sort of thing. Yes? In biology, you dissect stuff. But they usually have virtual dissection options for people who don't like dissecting things. I love dissecting things. I thought it was fascinating. I was like, oh, this is so cool, right? Not in like a creepy way, but I was just like, it was just fascinating to see all the inside parts. We dissected a frog in grade 9 because back in the day, it used to be the like digestive system and respiratory system and stuff in grade 9. You would open the frog and you'd see all the various organs that did all the various things, which was very cool. Yes? You are allowed to take as many as you want to. And I'm also going to put in a big plug for environmental science. It's probably going to run as a like grade 11/12 course, which means that if you choose to sort of do the extending part of it, you'll get credit for a grade 12 course. If you choose not to do the extending part of it, you'll get credit for a grade 11 course. Any of those 4 options will get you into university, okay? And environmental science, hugely important these days, yes, okay, because there's so many issues in the environment, so you'll learn how they happen, you know, how are humans causing this, what can we do to make some changes to make it better, yes. What about biology? Biology is the study of living things. So biology and environmental science actually mesh quite nicely together. Environmental science is a branch of biology, okay? But it also involves some chemistry and stuff when you look at like what's happening in the atmosphere, maybe what's happening in the oceans, right? So that would be more the environmental side of things. So biology, you would be, like I said, in grade 11, looking at all sorts of different living creatures. So you would look and say, like, there's going to be a unit where you study worms. There's going to be, you're going to study all the arachnids, all the insects, all the mammals, all the sponges, and like stuff that you would find at the aquarium, all the fishies and various stuff. It's very cool. I loved biology. It was actually my favorite subject in high school, but I ended up teaching chemistry because I like teaching it better. It's always right and always wrong, and I don't have to read as many answers written in poor grammar. Did I say that? I did say that. Now, there is a 5th option. So there's biology, chemistry, physics, environmental science. The 5th option is really if you are, it's called, what's it called? Science for Citizens. And it's mostly an option for people who are sort of like in an alt program, right? Are having trouble attending school for whatever reason. Maybe it's like a mental health issue or, you know, and they just need a Science 11 to graduate. Yes? So it doesn't involve like a lot of homework. Most of the work is done in class. But there is a certain, you know, there's certain people who that's what's going to work for their life at that point in their life, right? So all of those are excellent options. If you have any questions about them more specifically, ask me. Biology, chemistry, physics all have enriched versions at the grade 11 level. If you're interested in doing AP, you would want to do those enriched options in grade 11. AP is advanced placement, means you can get university credit. And if you want to talk more about that another day, we will talk more about that another day. Is good? I will remind you of all of this near the end of January because you'll be doing course selection then. But I've had a few people ask me already, so I think it's good to just, you know, go over it now so you can start thinking about things. Start thinking. All right. So we're going to carry on here.
So boron comes in these 2 versions. Now the thing is, there is not an equal number of boron 10 atoms and boron 11 atoms. In fact, if we pulled 50 boron atoms at random and represented them here, we'd see that the majority of the boron atoms are boron 11, which I'm indicating with little orange circles here. Okay?
So on yours, the little gray circles are boron 11, and the little white circles are boron 10. Yes? That's exactly what it is. The atomic mass is the average of all the isotopes, and that's why we can end up with a decimal number when we're averaging them all out. Okay, and let's take a look at how that math looks. You don't need to be able to do the math, but it will be nice to have seen it once. If you take Chemistry 11, you will do the math. If you're interested in learning how to do that, let me know. I can provide you with materials.
Okay, most of them are boron 11, and only a small minority of them are boron 10 atoms. We can look at this on a pie chart just to get this point home, and you can see that the vast majority of them are boron 11 with a smaller amount that's boron 10. If you crank through the math here, you'll find out that about 20% of the boron atoms in the world are boron 10, whereas 80% of them are boron 11.
Okay, so fill that in the boxes at the top. About 20% are boron 10, about 80% are boron 11.
This leads us to the idea of atomic mass. Now, atomic mass asks what is the average mass of a boron atom. All right? We've got these two types of boron atoms. We've got boron 10 that weighs 10 AMU. That's what its mass is. And we've got boron 11, which weighs 11 AMU. That's what its mass is. But here's the thing. There's only 20% of this guy and 80% of this guy. So now we're asking, got these two types of boron, what is the average mass of a boron atom? Now, you might think average and say that's pretty easy. I know how to take an average. This guy weighs 10, this guy weighs 11. So why don't I just add the two of them up, 10 plus 11, and divide by 2? And then I'll get 10.5, right? That's how I take an average.
You can fill in that 10.5 in the little circle that has an X beside it and says nope, because that's not the actual answer. You can see the average mass of boron is not 10.5, it is actually 10.8. So in that little circle where it says 10 plus 11 divided by 2, you can write 10.5. And if you want to X it out, you can, because it's wrong. Okay? But often people think I'm taking an average, just add them up and divide by 2.
Okay? No, it's wrong. That is one way that you can take an average, but it won't work here. And the reason why is because this type of thing, added up and divided by 2, assumes that we have the same amount of both of these. If we had 50% boron 10 and 50% boron 11, then we could just add them up and divide by 2. But we can't do that because we have different amounts of these two types of atom. Okay? And we have to come up with a mathematical equation that's more complex than...
Now, if anyone really wants to challenge themselves, this is only for those of you who love math, can you think of a formula that would allow you to calculate that 10.8? This is super duper challenge here. And it's okay if you can't. I probably couldn't have done it when I was in grade 9. I wouldn't have come up with it anyway. Use the numbers 10 and 11 and the 20% and 80% to come up with 10.8. You got it? Cool. You got it? Yeah. How many people think they got it? Oh, a number of you, very good. I don't think I would have gotten it in grade 9, but that's pretty cool. Let's check and see.
And this, to take into account the different amounts that we have of these two atoms. Here's how we do it. We take the fact that there are 20% boron 10 atoms, and that they weigh 10 AMU each, so 20% times 10 AMU. And then we add that to 80%, which is over here, times 11 AMU.
And hopefully you know that when you want 20% of something, you don't go 20 times, you go 0.2 times, and you go 0.8 times. And if you didn't follow any of that, that's okay. You don't need to be able to do that calculation, okay? But if you are interested, here it is.
And we do that math, we have to convert the percentages into decimals. But when we crank through this, we end up with 10.8 AMU. And this tells us what the average weight of a boron atom is, taking into mind that only 20% of the boron atoms out there are boron 10, and 80% of the boron atoms out there are boron 11. Now check this out. The number that we get here, 10.8 AMU, is what's the bottom of this element name on the periodic table. So that's what this number is. It's the atomic mass that tells you what the average weight of one of these boron atoms is. Now we said we had these two different types that weigh 10 AMU or 11 AMU. Look at the average. The average is 10.8.
Is 10.8 closer to 10 or closer to 11? It's closer to 11, and why is that? Because we have more of the 11 isotope.
Which is much closer to 11 than it is to 10. And that makes sense, because since we have so many more of these and they weigh more, the average for these two types should end up closer to this, just because we have so many more.
Okay, we're going to pause there. Okay, and because we have a long weekend, I want to show you how to do one more thing before I send you off, okay? So atoms in the periodic table, and I want to go to here. No, not that one. That one. Okay. This is for the quiz for next Friday. Okay, I'm just introducing it so you can see a little bit of it this weekend, and we'll cover it more next week. Okay? So you know that the atomic number, this is on page 90. Page 90. You know, I hope, that the atomic number is equal to the number of protons. And you know that the atomic mass is not the mass number. Okay? So those are two things you should know, what you can get from the periodic table. So on this page, you just need to know that the number of protons is equal to the atomic number. And so you'll be asked, based on either the name or the symbol or the atomic number or the number of protons, to fill in all the other boxes. But what's really nice is, what do you know about the atomic number and the number of protons? They are the same. So you'll be able to figure that out. And if you know the atomic number, you can go and look and find out which element it is. Does that make sense? Do we think we could do this box on the weekend? Excellent. We're going to go see if we can do the next box. So on our next page, we know, because we learned it yesterday and today, that the mass number is equal to the protons plus the neutrons. That means, yes? No? Okay. That means that if I give you the mass number and the number of neutrons, could you calculate the protons? Yes. If I gave you the mass number and the number of protons, could you calculate the neutrons? Yes. So if I give you the protons and the neutrons, could you calculate the mass number? Yes. So here what you're going to do is you're going to go through and you're going to say, oh, look, I have the mass number, and I know that it is chromium. Could I go and figure out the number of protons in chromium? I can always go look up the atomic number. Does that make sense? Like I can go and find chromium, right? And it says, up at the top, it says 24. And so I know now that this is 24, and everything else just falls into place. Okay? Remember, this number is not on the periodic table. This number here is the protons plus the neutrons. Okay, so for homework for the weekend, and if you think you're really fancy and you want to go ahead and do page 92, you can do that as well, but I'm not going to require it of you. So for homework, I would like you to do page 86. We have a long weekend, so there'll be a little more than usual. I'm sorry, I know that's how it goes. You're going to do page 86, page 87. No, not 87. Page 89. Actually, no, let's not do page 89. I'm going to take that out because you have a quiz to study for as well. Okay. So page 86, page 90, and page 91, and you're going to study for your quiz. Now, in order to study for the quiz, would you like a blank copy of what the quiz will look like? What your quiz is going to look like on Monday? Wouldn't that be lovely? Yeah, so why don't we do that? Now, the only thing is, if you're doing the enriched version, you can just cover up this first column. It actually explains in here. If you're confused by it, let me know, okay? So, anyone know those? you'll notice that I've written the names chalcogens and pnictogens on there. You do not need to know those. It's just to show you how you can write sideways. Okay? You don't have to write anything if it doesn't have a letter. Okay? So you're just doing, okay, so these are part of the main group elements, so that's not the main group. Okay? And if you want less homework next week, I'll put up some optional pages. Okay, so these are the work ahead pages. Is page 89. Yeah. And page 90. 92 and 93. So those are just if you want to work ahead if you're like bored. Okay? If you are feeling like you would like to know about something else in more depth and you've finished all of the enriched stuff, let me know. We can maybe tailor another little enriched package to you if you are interested. Okay? I'm not going to make a whole bunch of copies of this. Great. Yeah, sure. And if anyone wants an extra copy of the practice quiz, I'll just put them at the back near the free blank paper. Okay. So if you're like, I want another copy, you can. Oh, and I will post up the answer key on Teams. Is good? Did you guys catch that? Practice quiz, where will the answer key be? On Teams. Everyone over here, where will the answer key practice quiz be? On Teams. And I'll at you, so like it'll give you a notification. Okay, I'll put it up this weekend. Probably tomorrow.